Unit 1, Objective 2, Simplifying Square Roots with Variables, Notes, Day 2. So in Notes Day 1, all of the exponents underneath the radical were even. So all the exponents on the variables. In Day 2, we are going to learn how to simplify variables with exponents that are odd numbers. So we'll start with simplifying the square root of a cubed. If we expand the term a cubed under the square root, we will get a times a times a. And as we reviewed in the last notes, we know that every time there is a pair of letters or numbers under a square root, one of them comes out. And so we see we have a pair of a's, so that's going to give me 1a out of the radical, and then 1a remaining in the radical. So the square root of a cubed reduces to a square root a, or we can say a root a. The square root of a to the fifth expands to a times a times a times a times a. And again, we're looking for pairs. So here's a pair of a's. Here is a second pair of a's. So each time we would have one a that would come out of the radical. And what do we do with those a's? We multiply them. So that's going to give us a squared root 1a remaining inside. So to summarize, when we simplify square roots with variables, you want to find pairs of variables. The number of pairs tells you the variable's exponent when you remove the square root. If there are any remaining variables that do not make a pair, they stay inside of the square root, or it stays inside of the square root. All right, so let's do some examples. The square root of x cubed, y cubed. Simplify the following by expanding. Then circle the pairs of variables that can be simplified out. So we would expand this root to x times x times x times y times y times y. So x cubed becomes 3x's multiplied, y cubed becomes 3y's multiplied. We're going to circle our pair of x's, and we're going to circle our pair of y's. That will mean that one x will come out of the radical and one y, and we would leave them listed as the term xy because we can't combine them anymore. And what remains under the square root is a x and a y. Let's try b. We're going to expand, so we'll write that as the square root of 36 times a times b times b times b. All right, 36 is a perfect square, so we know that's going to come out. And here is a pair of b's. And so that's going to give us 6b, 1b is going to come out, root 1a remains and a b remains. Okay, third example. Root r times p times p times p times p times p times q. So we've got 2 r's, 5 p's, and 1 q. And again, we're going to circle the pairs. So here's a pair, here's a pair, here's a pair. So we know 1r is going to come out, and that was from last objective. The square root of r squared is just r, even exponent, you divide by 2. There's 2 p's that are coming out, so that's p squared. There is 1 p that remains along with 1 q that remains. Okay, so So what do we do when we have really large exponents and maybe we don't want to write out the expansion? Well, the shortcut is going to be that you're going to take the exponent and again divide by 2 like we did when we have even exponents, and then whatever is left over is what remains inside. So when you have a to the 11th, that is going to be 5 sets of 2 or 5 pairs of a's. There's still going to be an a that remains inside. B to the 22, there are exactly 11 pairs with no b's remaining inside. So I can trim up that radical. For E, the square root of 50, x to the 5th, y to the 7th. So we know we're going to break down the square root of 50. That's going to be root 25 times root 2. And then again, we're going to look at the x to the 5th and determine how many pairs, and then the y to the 7th and to determine how many pairs. So root 25 is going to give us 5. Remembering that 2 remains inside. So you need to stay organized to keep track of what is outside of the radical and what is inside of the radical. X to the 5th, that's going to be 2 pairs with 1 remaining. So think about it. And if you can't do it mental math, then write out 1, 2, 3, 4, 5, and then go ahead and circle your pairs so you can determine how many are coming out. Y to the 7th, that's going to be 3 pairs with a y left over. Letter F, root 10 does not reduce. X to the 9th, that's going to be 4 pairs. And again, we have an x left over. But we also have that 10 that didn't simplify. Y to the 4th, there's 2 pairs. That's an even exponent. And the z remains inside because there's only a single z. 1g. We have a 3 out front so that we know whatever number comes out of the radical is going to multiply that 3. So that's going to give us root 4 and root 3. So 12 factors into 4 times 3. Root 4 is 2, and it's going to multiply that 3. So that's going to be a 6 for the number outside and a 3 for the number inside. So that takes care of the number part. X to the 7th, how many pairs? There's 3 pairs in x to the 7th with 1 left over. And again, so that's basically 7 divides 2 3 times with 1 left over. If that is troublesome, you can always write out 1, 2, 3, 4, 5, 6, 7, and then you can circle your pairs, circle your pairs, circle your pairs. So you can see that you have x to the 3rd, 3 x's come out, 1 x remains. All right, I'm going to have you pause the Edpuzzle video and do letter A, 2A on your own, and then record your answer. Okay, 2A, we have root 10 is going to stay inside. There's going to be a to the 5th that comes out with 1a left inside. So 11 divides 2 5 times with 1 left over. B to the 22 is going to give you b to the 11th. That divides evenly. No b's left over. And C. So now you're going to answer the next question. Did you get it right? For B, go ahead and pause the video, answer the question, and then you can restart and see if you got it right. Okay, so that's going to be root 9 times root 7. 9 times 7 is 63. That root 9 is 3. It comes out and multiplies the 7, and that's 21. X to the third, there's 1 pair. It's going to come out and multiply the 1 that's already there and get x squared. There's still 1x left inside. Y to the 9th, 9 divides 2 4 times. And let's see what's left over. We've got a 7 left over, an x left over, and a y left over. Did you get it right? 2C. I'm going to pause again and let you try it. Put your answer in Edpuzzle and then check to see if you're right. All right, we're going to break down root 18. And again, that's root 9 and root 2. 9 roots to 3. 3 multiplies a half. And you can either write it as 1.5 or 3 over 2. I'm going to write it as 3 over 2. We still have a 2 left under the radical. X to the 0 is 1, remembering our rule of exponents. Y to the 5th, there's 2 pairs with 1 left over. And then the Z, there are no pairs, so it stays inside. So did you get it right? All right, let's move on to multiplication examples. So for multiplying, for the first one, it's not multiplying, it's just simplifying. Again, it's similar to the ones we just did, but we will end up having to multiply what comes out of the radical by what's sitting there to begin with. So we see we have 5x cubed y. So when we look at x to the 5th, that's 2 pairs coming out. So that's x squared coming out. There's already an x to the 3rd. So you have to remember, what do you do when you have x squared times x to the 3rd? Well, that goes back to Unit P and our rules of exponents. That's going to give us x to the 5th. There still is an x remaining under the radical. Square root of y squared is y. The y comes out, and it multiplies the y that's already there. That gives us y squared. So I'm just going to trim that up a little since we didn't need that full radical. All right, let's talk about multiplying. As we saw in Objective 1, multiplying radicals involves multiplying outside numbers and variables to outside numbers and variables, and then inside numbers and variables to inside numbers and variables. So you can see that both of these are inside of the square root, and so I can multiply them. So when I do, I have to follow normal 8 times 3 is 24. B to the 3rd times B to the 5th, you have to follow your rules of exponents. So that's adding the exponents, so that's B to the 8. After you do that, you are expected to simplify what's remaining or what you get. So root 24, root 4, root 6. That's going to give me a 2 on the outside with a 6 on the inside. Root B to the 8. 8 divides 2 4 times. So there are 4 pairs. So 2b to the 4th, root 6. For C, there are a couple different ways you can do it, but as I'm looking at it right now, and I see the 49 and the 9, my brain thinks, oh, those are perfect squares. So I think I'm going to simplify that part first before I do anything else with the problem. So this is going to become 7 root AB cubed times 3 root A squared B. Now I don't have numbers inside anymore, so that means when I'm done, I don't have to reduce any number part of the radical. So now I'm going to multiply outside numbers to outside number. That's 21. Inside terms to inside terms. That's going to give me A to the 3rd, B to the 4th. And now I'm going to simplify. There's 1 pair of A's, so that's 21A, and 2 pairs of B's. remaining a. And that's multiplying. Dividing. For dividing. Just like we learned in the first objective, when you're dividing, you should reduce as much of the radical as you can to begin with before you do anything else. So if I look at 4a, I see that 3 divides into 12 4 times. So now the problem becomes root 4 x to the 4th, y to the 3rd. And now I go about the process that I did before. So I'm going to pause the video now and let you finish the problem. Record your answer in Edpuzzle. Okay, so let's see what you got. Root 4 is 2. Root x to the 4th is x squared. And root y to the 3rd, 1y comes out with 1y remaining. Did you get it right? B. Again, I'm reinforcing that you should divide whatever you can that is under the radical to simplify first. So if I'm looking at this, I see that the 2 is under the radical and the 24 is under the radical. I'm allowed to divide those. You get 12. X under the radical, x to the 8th. Using the rules of exponents, you're going to get x to the 7th. Subtract when you're in division. Y to the 3 over y, you're going to get y to the 2. Outside the radical, 2 and 4 reduces to 1 and 2. So we had a lot of reducing in that fraction. Let's see what's left. In the numerator, I have 12 x to the 7th, y to the 2 under the square root. That 1 is not necessary, over 2. Now let's keep simplifying. Root 12, I'm going to break down into root 4, root 3. So that's 2 root 3. X to the 7, so we're going to figure out how many pairs there are in 7. So 7 divides 2 is 3. So that's going to be x to the 3rd. And then what's left is 3y squared over 2. Still have that 2 in the denominator. Root y squared, we can take that out. That's going to be 2x cubed y root 3 over 2. And so our final answer will involve reducing the 2's, and we're going to get x cubed y root 3. Some of them are a little bit longer like that. Okay, last example in dividing. So if I look at this one, I see that I have 2 a's in the numerator. So I'm not quite sure why, but those a's could be combined, giving you a to the 20th. Well, if you'd use the rule of exponents and you have a to the 20th on the top and a to the 13th in the bottom, that's going to give you root 24a to the 7th, because 20 subtract 13 is 7. So I'm going to pause now and let you reduce that radical and put your answer in Edpuzzle. Okay, so that's going to be root 6 and root 4, because 4 times 6 is 24. That 4 comes out as a 2, and it multiplies the negative 5, and you get negative 10. A to the 7th, there are 3 pairs. There's 1 pair already out there, so that's a to the 4th. What's left is a 6 and a remaining a. All right, let's go on down to some geometry problems, okay? Number 5, so the geometry involves remembering some formulas. So let's talk about the area of a parallelogram. That's base times height. I'm going to go ahead and shade the base and the height, and they are always found because they are connected at a right angle. We remember from parallelograms that opposite sides are the same length. So this is the square root of 6x to the 5th. And so to find the area, it's just a matter of multiplying those two radical expressions. So it's going to be 2 root 12x to the 4th multiplied by root 6x to the 5th. That's going to give us 2 root 72x to the 9th. And now we practice what this objective has been about. Simplifying root 72 and then figuring out how many pairs of x's there are in x to the 9th. Now for me, root 72, I always go over and I think about my perfect squares. And I figure out the largest perfect square that divides into 72. And that's going to be 36. Now you could have divided by 4, you could have divided by 9, but that's not the largest perfect square. So if you choose 36, it is a one-step reducing for 72. So root 36 is 6, multiplies that 2, and you get 12. X to the 9th, there are 4 pairs, so that's x to the 4th. And what's remaining is a 2 and an x. And that's area of a parallelogram, base times height. Area of a triangle, so it's good to review our geometric formulas. 1/2 base times height. And again, let's talk about the base and height of geometric figures. They are connected at the right angle. They're connected at the right angle. So you might also see the area written as base times height divided by 2. Both of those are the same formula for finding the area. So you can use either one. So 1/2 times root 8ab to the 7th times root 10a to the 4th b to the 0. So now you've got some simplifying to do with the radicals and the variables. All right, so we can go ahead and multiply if you want first, and then you could simplify. So that's 1/2 times root 80 a to the 5th, and then that b to the 0 is 1, so we truly just have b to the 7th. Now I'm going to go ahead and let you simplify the root 80 a to the 5th, b to the 7th, and then multiply whatever number comes out by 1/2, and then record your answer in Edpuzzle. Okay, so root 80 is going to be root 16 times root 5. Root 16 is 4. The 4 is going to multiply the 1/2, and you're going to have a 2 that comes out with that 5 still remaining inside. A to the 5th, how many pairs of a's? 2, with 1 staying inside. B to the 7th, 3 pairs with 1 b remaining inside. Okay, our last one is the extension, and these always kind of seem a little more challenging, but it's still good for you to practice higher level thinking of the skill. So the question says to simplify the expression. And so you're going to do it in parts. You're going to first begin by simplifying 12x root 20x cubed y. So the 20 is going to break down just like normal square root. So root 4, root 5. Root 4 is 2. It's going to multiply that 12, and we're going to get 24. X cubed has 1 pair of x's. That's going to come out and multiply that other x. That's going to give me x squared. Remaining 5xy. Then we're going to do the same thing to simplify 4 radical 45x to the 5th y. So I'm going to pause the video and let you practice that problem and then record your answer in Edpuzzle. Okay, root 45 is going to be root 9 times root 5. Root 9 is 3 times 4 is 12. X to the 5th, there's 2 pairs. And then what's remaining is a 5, an x, and a y. So there's that leftover x. And then it says, why is it possible to subtract the two terms? Because they are like terms. And so when you subtract them, you're going to get 24x squared root 5xy minus 12x squared root 5xy. And let's do a little reminding. They're like radicals because they have exactly the same term under the radical. And so when we subtract them, all we have to do is subtract what's in front of the radical. So 24x squared minus 12x squared is 12x squared root 5xy. And that's your answer.